All right, and then on that note, why don't we move on to the next part of the pancreas, which is known as the endocrine pancreas. And this is actually the part of the pancreas that is the most famous. We hear the most about this, as we'll see in a minute, because it has a lot to do with diabetes. The endocrine pancreas will release hormones. Rather than the salts or enzymes we saw above, will release hormones that go into the bloodstream. And they will move on elsewhere throughout the body to the liver, perhaps the intestine, or even as far as muscles to cause things to happen. And the way the endocrine pancreas is organized is that there are many islet cells. It's actually pronounced islet, but I'm mispronouncing it just to let you know how it's spelled. Islet or islet cells that exist and sit in islands. Sit in islands. So there are three main types of islet cells we're going to talk about, and they're all present to some extent in each island or group of cells in the pancreas. And let's go through them one by one. So first of all, we've got what are called alpha islet cells. Alpha islet cells, and these guys release a hormone that's called glucagon. Glucagon. And the main function of glucagon is to take things like glycogen, which is a whole bunch of glucose molecules that are stacked up on top of each other, and then break them down into smaller glucose monomers or molecules. And so we're making glucose from glycogen whenever we release our glucagon. So I'll write glucagon up here. And it's not just carbohydrates, but glucagon is responsible for the breakdown of a whole bunch of macromolecules. So I'll just drive it home by writing glucagon causes breakdown over here. The next type of islet cell that we have, and perhaps the most famous of them all, are our beta islet cells. So our beta islet cells house and release insulin. Now, when you hear insulin, there should be a lot of light bulbs coming up, because insulin is responsible for a whole bunch of things. For one, when we look over here, insulin is what causes the opposite of this reaction, where instead of breaking down glycogen into glucose, insulin causes glucose to be stored or built up into glycogen. So insulin does the exact opposite. And again, to drive that home, it's not just for carbohydrates, but it's a whole bunch of things that get built up. So I'll write insulin is responsible for the buildup or storage of our macromolecules. But what might be the most important thing to mention about insulin is that it is the hormone that is related to or responsible for the disease known as diabetes. And gosh, we can have entire tutorials on diabetes and what it does and what it means. But for right now, just know at its bare basics, diabetes occurs or causes damage to our bodies because we have too much glucose. Too much glucose floating around in our body, too much sugar, all right? And that happens because insulin is not working properly. We're not building up and storing glucose in glycogen like we're supposed to be doing. Instead, it's running all over the body. And because of that, we have what's called eye, nerve, and kidney disease. That's sort of the catchphrase we use in medicine to describe diabetes. It's eye, nerve, and kidney disease, because with too much glucose over time, we're unable to see. The nerves, most commonly in our feet, are not able to sense pricks or things or damage that occurs there, and eventually they could cause amputation. And our kidneys stop working over time, which could lead to dialysis, and that causes early death. And in addition to these three, glucose goes all over the body and causes a whole bunch of other things like earlier onset heart attack and other types of complications. The other thing I should mention about diabetes is that there are two types of diabetes. There are two types. There is type 1 diabetes and there is type 2. And the way you differentiate type 1 versus type 2 diabetes is based on how it's caused. And this all points back to insulin. In type 1 diabetes, we have no insulin. So the person that has type 1 diabetes has no insulin production. And because of that, we're not able to store our sugar in glycogen. We're not able to put it away. And so we have it all over the place that causes eye, nerve, and kidney disease, among other complications. In type 2 diabetes, your insulin receptors, so you have insulin that's being produced, but your insulin receptors are broken. Your insulin receptors are broken, so even if we do produce insulin and it goes to where it's supposed to go in our body, these receptors will not respond. And so it's as if we don't have insulin in our body at all. And there's so much more that we can say here, but we'll close our conversation on diabetes for now, and we'll revisit this later. Let's move on to the third type of islet cell that we've got in the pancreas, and those are delta islet cells. Delta islet cells, and these are the guys that release a hormone called somatostatin. Somatostatin, which is the major party-pooping hormone released from the endocrine pancreas, because its main job is to stop the jobs of all the other hormones that are active. And these hormones can include things like what we've talked about here, glucagon, insulin, but there are other hormones that are also in play in the GI tract that include things like cholecystokinin that we talk about elsewhere. And somatostatin will go in and cause the effects of those hormones to stop. And that's sort of its main role there. So that's our endocrine pancreas, and as we talked about earlier, our exocrine pancreas. So the pancreas is responsible for a lot. No wonder surgeons have the phrase, eat when you can, sleep when you can, and don't mess with the pancreas.